Good evening. Today is Friday, January the 22nd. Today in pre-calculus, we looked at a concept called linear programming, which is used to solve different types of problems. So I will share my screen and show you an example of linear programming. So what we're talking about here is linear programming. And it has nothing to do with programming computers, but what it is, it's a concept to solve real world type problems. So I'll give you an example here of the problem we're looking at. We have a sawmill or a lumber yard, and the lumber yard has to make plywood. So we're looking at plywood and lumber. That's the choice we make. Now we have capability for 600 units per week. Requirements are we have to make at least 150 units of lumber and 225 units of plywood. Now, profit is $30 for lumber and $45 for plywood. So we establish constraint equations. So what we've got here, if you look, we are trying to maximize profit. So my objective function here, if I let plywood be P and lumber be L, my objective function here is F of P/L, plywood / lumber equals, okay, it's 45P plus 30L. Now that is what's called the objective function. And the objective function is what I'm either trying to maximize or minimize. Now I have constraint equations here, so we'll look at what are called constraint equations. And the constraint equations here, of course, first, I have 600 units of capacity, so I will do P plus L is less than or equal to 600. Less than or equal to 600. Now, I have to make at least 150 units of lumber, so L has got to be greater than or equal to 150, and plywood, so that's P, has got to be greater than or equal to 225. So if I come over here now, if you look in a real world situation, of course, the other constraints that we really don't normally put down, but L has got to be, in this case, it's greater than 150, so greater than 0 is not a constraining situation. So if I come over here now and draw my graph, and this is it. See, my graph is all in the first quadrant because, as I said, you can't make negative things, right? So there's my y-axis and here's my x-axis. Now in this case, since if you'll notice, see, I am talking P and L, I will make my x-axis the p-axis. I will make my y-axis the L-axis, okay? So now I'm going to come down here. If I look at my P plus L less than or equal to 600, if L is 0, then P is 600. So I have a point out here, which is 600 comma 0. And by the same token, if I let P be 0, then I would have a point up here somewhere, which is 0 comma 600. So 0 comma 600. So this constraint equation is linear. So I would draw my equation from here to here. Now, I have to be less than or equal to that. So with that constraint, I'm somewhere down here in this triangle. Now, if you'll notice, it says that P has got to be greater than or equal to 225. So if I come down here and draw my vertical line here, something like this, and this is P equals 225. Now, I have to be to the right of this. So now my constraint equation is this triangle in here. And then my final constraint is L, it's got to be greater than or equal to 150. So that's a horizontal line that looks somewhere like this. So it goes across about like this. And this is L equals 150. Now, so my feasible region, I come in here, the text, the feasible region is this small triangle right in here, because any point inside this small triangle here satisfies all three of the constraint equations. Now, the interesting thing about this whole exercise is that the maximum or minimum point for our objective function over here will occur at one of the vertices of the feasible region. So I don't have to sit here and try to guess that there's some point out here in the middle that's going to be better. So I have a point here if I look. So this coordinate right here is P is 225. So I have 225 here. And if I subtract 225 from 600, then that is 375. So that coordinate right there is 225 and 375. Now, this coordinate down here is 150 and 450, because once again, it's got to add to 600. So this is 450 and 150. And then the final point over here is this coordinate right here, which is, of course, 225 and 150. So this is 225 and 150. Now, so as I said, the maximum point will occur at one of these points. So I'll come back up here and kind of type this in. So I have my objective function. So f parentheses 225 comma 150 is equal to 45 times 225 plus 30 times 150. And if I get my calculator out here, if you put this in your calculator, you get 45 times 225 plus 30 times 150, which is equal to 14,625. 14,625. Now, so that's how much I would make if I made 225 units of plywood and 150 units of lumber. Now, so if we come down here, the next thing we get the next point up there, which is 225 and 375, and that's equal to 45 times 225 plus 30 times 375, and that's equal to 21,375. So 21,375. Okay. Now the final point we have to look at is the point over here, which is F parentheses 450, comma 150, which is equal to 45 times 450 plus 30 times 150, and that equals 45 times 450 plus 30 times 150 equals 24,750. So as you can see, if you look at these 3 points, the greatest profit occurs here at the point 450 and 150, where I get 24,750. So the result of this analysis says that I would make 450 units of plywood and 150 units of lumber to maximize my profit. So that's what linear programming is all about. We'll look again on Monday a little bit more, because there are some situations where you can get the same result along a given edge. So then you have an option to operate at any one of the points, or you have something where there are no feasible solutions, or we can minimize. So I'll get back to you on Monday with this, so I'll stop sharing now. If you look at the schedule, Monday we will finish up this linear programming section. Tuesday we will do a review, and then Wednesday will be the Chapter 6 test. And Chapter 6 test now is all matrices. So I will send you some information on Sunday as to what the online test will be, so that you can begin working on that, and you can spend probably Monday, Tuesday, and Wednesday getting that done. So if you have any questions, as always, send me an email. Let me know where your problems are, and I'll get back to you. Have a good weekend.